Hello and welcome. I'm Dana Cowley with Hanford Mission Integration Solutions. For those of you here in the Richland Public Library, please note the exits. We have some here, down the hall, and then right out this window. If you're joining us virtually, we have added a link in the chat that will take you to all the meeting materials. And then, of course, this meeting is being recorded. We'll render that, post it to YouTube, and link it to the events calendar as soon as we can get to that. We welcome you to tonight's Department of Energy public meeting. This meeting is part of a Resource Conservation and Recovery Act Class 2 60-day public comment period. It's running through September 20th, so we have plenty of time to receive your comments. Tonight, we're here to discuss the proposed permit modification for a limited service life extension that will run through 2029. The extension is for the hose-in-hose transfer lines that are currently in use on the Hanford site. Those transfer lines move tank waste within the tank side cesium removal system. So for those of you who are just joining us here, when we're done, you can raise your hand if you have a question. If you're on the line, just drop your questions in the chat. And we'll begin with a presentation by DOE's Vivek Demain, and that will be followed by ecology with a regulator briefing by Dan McDonald. So thank you both for presenting. Go ahead.
Thanks, Dana. Good afternoon, everyone. My name is Vivek Demain. I'm the DOE Program Manager for tank site cesium removal facility, the TISCR facility, and I have been with DOE for over 5 years. And I work for Office of River Protections under the Tampon Programs Division. So, Department of Energy, DOE manages 56 million gallons of waste currently stored in underground tanks, and this waste was generated over 4 decades of petroleum productions, and this waste is handled through treatment, storage, and disposal processes. And the DOE has initiated the Direct Feed Low Activity Waste Program, or the DFLOW program, which integrates the multiple facilities and the projects all over the Hanford site, specifically to treat the low activity waste. And the treatment process for the low activity waste begins at the AP tank farm, which is shown in the yellow color rectangular area in the slides. And the AP farm provides the feed for the tank site cesium removal facility, TISCR facility, and also for the low activity waste facility. And adjacent to the AP farm is the tank site cesium removal facility, or the TISCR facility. And like its name says, it removes the solids and cesium that's present in the liquid waste. And once the TISCR processes the liquid waste, then that pre-treated waste is then sent back to one of the AP farm tanks. And if you follow the yellow color line that's originating from that rectangular box, it will take you all the way to the low activity waste facility. So the pre-treated waste that's stored in the AP farm tank is then pumped down to the low activity waste facility, WTP, the waste treatment plant low activity waste facility, facility where it is mixed with some glass forming materials and vitrified. And that vitrified low activity waste, or the pre-treated waste, is then transferred to the integrated disposal facility, or the IDF facility, which is shown by that purple color arrow at the top left corner of the slide. At the IDF facility, that vitrified waste is placed for long-term storage. Then during the vitrification process of the low activity waste, it also generates some secondary liquid waste. That secondary liquid waste is then transferred to the effluent management facility, or the EMF facility, which is shown by the navy blue color arrow in the picture. At the EMF facility, or the effluent management facility, the secondary liquid waste is evaporated, and that evaporated secondary liquid waste is then transferred to the liquid effluent retention facility, also known as the LUF. If you follow the white line that's originating from that EMF facility, will take you to the LUF, which is shown at the top right corner of this slide. And from the LUF, the secondary liquid waste is then pumped out to effluent treatment facility, where it is further processed and disposed. So there are multiple facilities, and that currently being upgraded and constructed. So in order to support the construction and the upgrade activities, it required changes or modifications to the Hanford dangerous waste permit. So today our focus is the modification or change to the TISCR facility dangerous waste permit or the RECRA permit in order to extend the service life of its housing host transfer line. So as mentioned earlier, the goal of Direct-Free Low Activity Waste Program, the DFL program, is to efficiently and effectively treat the low activity waste and subsequently vitrify them for the immobilization process. So the TISCR or the tax cesium removal facility being the part of a DFL program, it removes the solids and the cesium that's present in the liquid waste and let us into a facility for vitrification. Next one. So the Hanford, the previous fourth slide. Okay. So the Hanford regular dangerous waste permit, overseen by the Washington State Department of Ecology, regulates the waste management activities at the Hanford site. And the current revision, the revision 8C of the Hanford dangerous waste permit, which is governed by the again Washington State Department of Ecology, it dictates the waste treatment, storage, and disposal activities. And so the Department of Energy and our contractor, WRPS, Washington River Protection Solution, we as a permittee were proposing a class 2 permit modifications to the low activity waste pretreatment system operating unit group 1 section of this dangerous waste permit. Again, the intent of this permit modification is to extend the service life of this housing host transfer line.
A little echoey online, so we're gonna have you use that element instead. I think that will help. Sorry for the interruption.
Okay, got it. Thank you. Next slide, please. So this is the Hanford site map, and as you can see, the TISCR is located at the Hanford Central Plateau 200 East area, and the green color in the map shows the TISCR, sorry, the Hanford RECRA permit boundary. Next slide. So the tensile cesium removal system or the TISCR system is DOE's initial demonstration aiming to achieve the low activity waste pretreatment capability under the Direct-Free Low Activity Waste Program. And TISCR began processing waste since January of 2022. So January of 2022. And TISCR has so far, TISCR has processed over several 100,000 gallons of liquid waste. And as I mentioned earlier, the TISCR contains a filtration unit that removes the solids that's present in the liquid waste. And also it contains the ion exchange column, which is filled with a special type of media called the CST, the crystalline silicotitanate. That CST absorbs the cesium that's present in the liquid waste. As shown in the diagram over here, the TISCR facility or the tank site cesium removal facility is located adjacent to the AP tank farm. AP tank farm is one of our double shell tank farm. And the AP 107, one of the double shell tank farms, serves as the feed tank for the TISCR system. And the AP 108 tank serves as the reject tank, while as AP 106 serves as the storage tank for the pre-treated liquid waste. And all these tanks are interconnected to the TISCR process enclosure through the housing host transfer line. And the yellow color line in the graphics shows the housing host transfer line. Next slide, please. So as mentioned earlier, the tank site cesium removal facility or TISCR facility is DOE's initial demonstration of the phase one scope of the low activity waste pretreatment system or LABS project. So the TISCR hosing hose transfer line were permitted to facilitate the TISCR operations during this demonstration period. So TISCR will continue to operate until the phase two portion of this low activity waste treatment system project, so the LABS project is launched. So initially it was expected to start within the 5 years from the start of TISCR operations. And in the graphics over there on the left, you see the hosing hose transfer line being installed at the AP farm. And on the right is the jumpers connecting the hosing hose transfer line to the TISCR process enclosure. So there are 5 hosing hose transfer line transferring the liquid waste in out of the TISCR process enclosure. And each transfer line, hosing hose transfer line has its own unique line number, and they all differ in length. And then the graphic below shows that the hosing hose transfer line is comprised of 2-inch primary hose, which is encased inside the 4-inch secondary hose. And both the primary and secondary hose is further protected by an outer casing. And both the primary and secondary hose is made from EPDM rubber, which is ethylene propylene diene monomer type of rubber. And it is further reinforced by the steel wires and fabrics to ensure that the hosing hose transfer line is capable of transferring the liquid waste in and out of the transfer tanks. So the current permit mod states that the hosing hose transfer line, the TISCR hosing hose transfer line, has a 3-year service life, and after 3 years, the TISCR hosing hose transfer line will be replaced by another source of transfer line. And any uses of the TISCR system beyond this initial demonstration period will require hardware parking. So we are proposing a permit modifications to allow a limited service life extension of this transfer line, this TISCR hosing hose transfer line until 2029. That is 10 years from the manufacture of the TISCR hosing hose transfer line. And this extension will allow TISCR to continue treating the liquid waste until the phase 2 of the low activity waste pretreatment system projects, or the LABS projects, is launched as the following capability for continuing the pretreatment of the liquid waste. So as part of monitoring the hosing hose transfer line, TISCR hosing hose transfer line, there are leak detectors installed at the low point of each transfer line. And also the TISCR operators perform the routine radiological survey of this transfer line, and at the end of each processing batches, these transfer lines are flushed. So far, no problems have been experienced with this TISCR hosing hose transfer line. And this TISCR hosing hose transfer line was procured under the same specification as the hosing hose transfer line that's currently being used for shingle shell tank retrieval operations, and the life extension methods that was established for the shingle shell tank retrieval operation hosing hose transfer line are proven to be successful. And a similar life extension engineering evaluation was also performed for the TISCR hosing hose transfer line. And this service life extension engineering evaluation is an established process which factors in multiple criteria like the processing conditions, chemical composition, radiation levels, ambient conditions, and other relevant factors to ensure that the integrity of this of the TISCR hosing hose transfer line is maintained during the extended use. So this proposed plans to permit modification would extend the service life of TISCR hosing hose transfer line from 3 years, that is from the start of his first use, to 10 years from the manufacture date, from the start of his manufacture date. So the first component of the Tiscur Bosinose transfer line was manufactured in May 1st of 2019. So we are proposing the service life extension of the Tiscur Bosinose transfer line till May 1st of 2029. As mentioned earlier, we performed a service life extension engineering evaluation for the Tiscur Bosinose transfer line, and that evaluation confirmed that the integrity of the Tiscur Bosinose transfer line will be maintained during this extended use. And in addition to that, an IQRP, independent qualified registered professional engineer certified that the factor that was evaluated during this evaluated service life extension will not degrade the Bosinose transfer line before its maximum life is reached. Next please. So this proposed permit mod will update the following section of the permit, which include the unit specific permit conditions. The next one is the addendum C, the process information section. And the next one is the appendix 2.11, the IQRP report section. And the last one is the appendix 2.15, the operating documents. And that brings to the end of my presentation.
Thank you, Vivek. And before we move on to how to submit your comments, I'd like to turn to ecology and receive the regulator presentation from Dan McDonald.
Thank you. Presentation is a stretch. With me tonight are team members, Kutaiba Abu-Ghazleh, permitting, Eddie Holbrook, acting deputy manager, Nako Shifrin, our permit coordinator, and all three of these folks help us stay honest. I'm Dan McDonald. I'm the project manager for waste treatment plant and associated facilities. This one happens to be one of the associated facilities. Got some prepared comments to go over with you this evening. First of all, this is great. We're glad to see this actually working. For those of you who noticed, he said several 100,000 gallons. We're a little over 700,000 now, I believe, that have been processed into AP 106. And the importance of this is the fact that waste treatment plant has certain waste acceptance criteria. This particular function, the TSCR function, is helping to get to the point where this waste is, if you will, conditioned and ready to meet the waste acceptance criteria at the waste treatment plant. This TSCR plays a vital role in getting this ready. So we're also looking forward to phase 2, which is called low activity waste pretreatment system, advanced modular pretreatment system. You've heard a variety of names if you've been in the system a while and have been paying attention, all of which are designed to get us to the point where we can process supernatant at a much greater rate than TSCR is doing now. Our hope is that we can, and help me, Tom and Vivek, if I get this wrong, roughly double it to beyond what TSCR is now. So the whole idea is to get us from this demonstration project into actual production, if you will. So we're hoping that this will do that. We do see this modification in supporting the successful and continuous operation of TSCR until phase 2 takes shape. And we look forward to seeing that. If you have any further specific technical comments or questions, I would refer you to either Tom or Vivek. And if there's something that we can help in the way of permitting, what I'll do is have you send me stuff and then I'll send it to Nalco because she knows what she's doing. Any questions for ecology at this point?
Thank you, Dan, and thank you to the WRPS, the DOE, and the ecology project team that all worked and collaborated to put this all together. You have until September 20th to submit your comments on the 60-day public comment period. We prefer them electronically, but of course, we'll take them via the mail. You can send them to Dana McFadden, Washington State Department of Ecology, 1300 Port of Benton Boulevard in Richland, Washington. That's 99354. And of course, we have all of this information on the Hanford.gov events calendar. So now we can get right to the questions.
If you will, not 1,300 to 3,100.
Oh, 3,100, you're right. Thank you. 3,100 Port of Benton Boulevard is the street address. Any questions here in the room? And Colleen, it looks like we have a couple of members of the public in the chat.
We do. We have a few members, and Liz Matson has a question. So Liz, can you unmute your mic and feel free to ask your question?
Can you hear me okay?
Yep, we can hear you.
Great. Thanks so much, and thanks for fixing the mic issue. That helped a lot. I guess I have kind of three interrelated questions about what does failure look like if there is a problem with the existing hose and hose transfer lines. If it fails, is there a backup system, or is there a way to fix it, or is it just wait until the LOP system is the next version is up and running?
So thanks for the question. So, as I mentioned earlier, so we are continuously monitoring the hose and hose transfer line. There are leak detectors that are installed. And as I mentioned earlier, like so far, we haven't experienced any problems with the hose and hose transfer line. But if the hose and hose transfer line failed, then I guess then our new options will be to replace it. And yeah, so did I answer the questions?
Yeah, it sounds like you can replace it. So the decision to just extend it from a 3-year use to 10-year use to get to the next system wasn't because is it because of an existing permit condition that says you have to go from the hose and hose, like I'm guessing like the softer lines to a hard line, or is it just like, is there a way you would replace it with another hose and hose line? I guess I'm not totally sure I understand like what if there's a condition on the replacement, like if it failed, would you have to replace it with a hard line, or would you replace it with the same kind of existing line?
So the current permit condition states that we can use this transfer line, the currently installed transfer line for 3 years. Then after 3 years, it requires us to replace with the new transfer line. And when we're done with the initial demonstration phase of the T-square, then we're required to replace with the hard wall piping. That's what the current condition says. But the reason why we're proposing for the extension is like these pipelines are, as I mentioned, like it's perfectly fine. It's working, and I guess from the government perspective, if we already have a functioning pipeline, then why are we have to spend the government money and to replace with the similar systems that are gonna, I guess, for maybe the work is can join. Anyone?
And
So-
just this might clarify. When you have to replace these eventually, they're going to be in a different location, or is it the same location?
So I have to follow up with our engineering teams and get back to you on that questions. I'm not sure, if we have to replace it, then we can replace it at the same spot and lay the new pipes at the same spot, or we can do it on the next spot. I'm not sure at the moment, but we can. If you submit it at the comments, then we can reach out to you and answer your questions.
And answer that question.
Okay. Yeah.
If you want. Do I need a microphone? So it's working, okay. My name's David Horton, I'm the engineering manager for the tank site season removal system for WRPS. If we were to replace those lines, the hose in hose transfer line, they would be in the same location. The 3-year life for the hose that's in the permit is a very conservative manufacturer's recommendation. They did an analysis a long time ago by the manufacturer, which is Riverbend, and they looked at the worst characteristics that could come from any of our tanks, which was U, S, and SX, the 3 tanks. And what they said was with the worst pressures, the worst temperatures, the worst chemical compositions, and the worst radioisotopes that the pipelines could see, if you combined all those 3, you would be at, they would guarantee the life of that hose-in-hose line for about 3 years. Obviously, our waste in AP farm is very dilute compared to those single shell tanks and what the lines are currently seeing. Plus, we're not using it at 100% capacity. Tisco works on a batch, so we run for about 4 weeks, and then we're down for 4 weeks while we change out ion exchange comps. So we run at about 50% capacity. So if you look at the analysis that we did for a life extension, which follows a protocol that's been used for about 10 years with the single shell tank retrieval groups, we can extend these to the 10-year, which is the maximum time, and we still have about 70% use of the line. So the permit, as Vivek said, was to replace them with a steel pipe after 3 years. And what we're looking at is replacing them, extending the life of the hose-in-hose rather than that steel pipe, which would cost the government in the region of $11 to $12 million. And so that it didn't seem the right approach. And I think that's why we're doing it. So that whether they were permanent lines of pipe, steel, stainless steel and carbon steel, or whether they were hose-in-hose, they would be in the same locations running from Tisco to AP6, AP7 and AP8.
Thank you. Liz, did that answer your question?
Yeah, that was helpful. Thanks. I have another question, but I'll wait if other people have questions in the room or online.
Thank you. Yes, let's check on the phone. If there are people on the phone only, press *6 to unmute and feel free to ask your question, please. *6. All right, I don't hear anyone on the phone only. I'll just assume we have no one who is calling in. I'm not seeing any hands raised here in the meeting. And so is there anyone else who's joining us virtually on Teams who would like to ask a question? See a couple of folks in the list of people who have joined who I don't recognize. No, apparently not. Liz, I guess it's all you. Please ask away.
This is a more general question about like how and I was trying to look up a map earlier where the new LOP system is located, or kind of how it works in relation to the existing system for Tisker. I feel like I should know this, but if someone could kind of like explain like how the LOP system is evolving while the system is online until 2029, or if there's plans to keep using this Tisker system at the same time as as I've heard it, Tisker on steroids. More of that bigger picture, if someone could explain that would be very helpful.
Would you like us to go back to one of the prior pages?
Yes. Yeah, the second page, I guess.
Page 2, the DF law page, please. That's the one.
So is the phase 2 portion of the law, so that's not the topic of today's presentations, but at this point, I'm not the program manager for the phase 2 portion, so I really can certainly point out like which section in the map, does the phase two portion is going to be built, but it should be close to the T-square periphery. So, yeah, I mean, right now, I think like the labs phase two portion, the ends, we just went through the city process. And I think we are, we are on track, to build or to bring the labs phase two portion online, before, before, so at this point, I really can't speak like on the phase two portion of the labs, but if you submit it as a comments, then we might be able to answer that one. Then, since it's not the topic of this presentation, so I'm really not sure where are we on the progress of the labs projects, the phase two portion.
Dan McDonald?
Liz, this is Dan McDonald. Are you there?
Yeah, I can hear you. Thanks, Dan.
What I would do, I would ask you to refer back to the recently completed settlement agreement. In there in the TPA section, you will find a milestone associated with the low activity waste pretreatment system. And there is a date in there, and that date, on that date is required initial engineering and design work associated with the system. At this particular point, all there is a lot of speculation on what the configuration of the LAWPS, if you will, phase two system is going to look like. But at this particular point, it's premature to be able to craft what that's going to look like, and at this point where it's likely to be located.
That's helpful. So it just is, I guess maybe we don't even know this yet. Is there I'm more curious if there would be, oh, the hoses are still good after 10 years. Let's just keep using this Tisker and the new LOP system. Or is it like a hard stop, like after 10 years, these hoses, we need to either replace them or move on to something else? Or maybe we haven't thought through that scenario yet.
So Liz, like I mentioned earlier, so the current permit model we are proposing to extend the service life of the hosing hose until 2029. And after that one, I guess the permit condition says that this has to be replaced with the hard wall pipe.
Okay, I see in the chat, we have Roxy Giddings who's joining us. Roxy, would you like to ask your question, please?
Yeah, I don't know how to work this machine that I'm working on. My son does all of this sort of thing, and I do everything on paper. But anyway, I was curious about how long this line is. I'm looking at the map, and I don't know which line it is. Is it the yellow line or the white one on the map?
Yeah, can you go to next? This one.
I can't understand you unless you really enunciate.
Let's go to slide number 8. So sorry, I forgot the name, but if you can see the slide, it shows the length of all the hosing hose transfer line.
Yeah, I can see it there. Yes. Okay. That's a lot of line to replace if it goes bad. I guess I have a general question. What do you do with all of this line work at the end of its life when you don't need it anymore?
Yeah, I'll refer that question to Tom and help answer that questions. What do you do after?
Yeah, this is Matt Covers. I'm the operations manager at WRPS. So At the completion, once we're done with the hose transfer line, that hose will eventually be removed once we're done with using that line. Did that answer your question?
My son's helping me now. I can't understand what you just said. Something, the only thing I could understand was, does that answer your question?
I'll speak up a little bit.
And
So-
there was an additional question, where would it be disposed?
So once the hose and hose transfer line, once we're done using that hose and hose transfer line will then eventually be removed. And then, disposal of that would most likely be in the. What's that word? The earth. It's ERDF, I forget what that stands for though.
Oh,
Environmental restoration disposal.
So, yes, environmental restoration disposal facility. Pretty reasonable to.
No, so there'll be a place for it, the environmental disposal facility.
Oh, so, okay.
That's the place where all of the pieces are going that are contaminated, that are physical pieces of the plant. Okay.
Can you hear him?
Yes, yes,
Yeah. Okay, I've got it now. Thank you.
you're welcome.
Thank you, Roxy. Did you have any other further questions?
No, I'm pretty ignorant. I was trying to figure out, I've been around in this a long time. I know that the single tanks are leaking. I know that some of or at least one of the double tanks is leaking, and I'm not sure where this cesium's being stored. Is it being stored actually in the building that you see when at the edge of the tanks, where the tanks are plugged in, and the cesium is being removed to that big facility, or is it being put into double-walled tanks waiting for the glassification?
So can we go to slide 6? So can you see the slide? And on the bottom right section of the slide, you see it says T-square cesium ion exchange column interim storage pad. So when the ion exchange column that's inside the tank site cesium removal system is saturated with the cesium, then those ion exchange columns are disconnected and moved to the storage pad that's shown over there. And then I think like in the graphics, you can see there are shown like 4 ion exchange column currently being placed over there. So that's where the removed cesium will be stored inside a ion exchange column. Did I answer your question?
And all of this is above ground, so it can be taken care of when we have to take care. I mean, everything that's touched is radioactive eventually, so everything that we put in now will have to be taken care of in some kind of a giant garbage dump. I'm having trouble with the scope of the process because I knew it was going to be big. I grew up in Pasco, 9 years in Pasco. And so I'm a downwinder, and I've been following this since the 1940s. So good luck with this. I hope it works. I hope we can keep these things working properly. And someday I hope we can get this glassification going, because it sounds like the one and only thing that we can do that will really protect us. But I wish that you would never, ever put the word safe in any of your documents, because I've lived long enough, I've seen enough to know that there is no safe place for radioactivity. It just does its thing, and there's nothing that human beings can do about it yet to really change it into something else. And that's the ultimate thing, to make it go in the circle around and recycle and all the things that we should be doing anyway. So I'm sorry we ever started this process, and I've looked at it from the very beginning. So anyway, thank you for having this hearing. I learned a lot, and I know that I should be looking at these pictures, and I'll try to get my son to help me again, and I'll look at them some more. So have another one of these days, okay?
Thank you, Roxy.
There's additional comment / input from Liz, and she said eventually the ion exchange columns have to go to a deep geologic repository. Is that correct?
I'll refer their questions to Tom.
My name is Tom Beam. I'm the Environmental Committee Manager for WRPS. The answer to that question is no, the current plan is not for those columns to go to a deep geologic repository. The current plan, although the details have not been worked out yet, is for those to be going to the VIT plant for processing at the tail end of the processing campaign. So the purpose of storing them on the storage pad here is to be able to put them in a safe configuration where they can sit there until a way is figured out to put them into the VIT plant, at the ion exchange meeting in the VIT plant. So I think that's the best answer.
All right, let's make one check around the room. Are there any questions in the room? And let's check on the phone one more time. If you're on the phone only, press *6 to unmute, and we'd love to answer your question. And not hearing anyone on the phone, let's go to the chat for the last round.
Just one more question. Liz was wondering about how many people we have in attendance tonight.
I would think I count 17 in the room total.
Okay.
And it looks like we have 9 people online, no one on the phone only, so.
And then, yeah.
And Liz, it looks like you and Roxy are our true members of the public joining us, so we appreciate your participation, both of you. We appreciate everyone's participation.
Did you have one last question, Liz?
Yeah, just a comment, knowing Roxy is wrapping her mind around all of this. So once the ion, if they figure out how to take the cesium ion exchange columns and put them through the high level waste vitrification facility, once it's vitrified, it does have to go to a deep geological repository. So kind of long term, the waste that's in these columns would end up in a deep geologic repository, just to help. I don't know if that's helpful to clarify that, but and please, if someone in the room that's not, and the issue with that, obviously, or maybe not obviously, is that we don't have a repository, so it would be stored at the Hanford site until a repository is found. So all of that's like many years in the future, but kind of the big picture. And correct me in the room if I said anything incorrectly there.
It's my understanding that there cannot be a deep repository in our area because of the way the land is covered with different layers of things from volcanoes and so on. And so if you start digging around down in there trying to make a place to put stuff, it can kind of implode on you by accident just by the rocks movement, and they just kind of blow up, and you can't put stuff down there because you can't trust the rocks to stay where they should. That's what I understand about the deep repository. The other thing is, think that we should allow any more radioactive waste to come into our state to be taken care of by anybody, anywhere, anytime. And that's the law. As far as I know, they haven't changed the law that if we can't take care of everything here ourselves for what we have, we should not accept anything from anyone else. And so I'm very concerned about these new little plants that think they're going to stick up all over on campuses and things like that, that they will have radioactive waste left over and they will need to get rid of it. And I do not think we should accept it. And I think they should know it now that we will not accept it because we are still struggling to take care of our own. And we have a whole river to save. And I really think that we should put our foot down.
Right, Roxy, you make some very good points. And as a friendly reminder, all comments need to be submitted in writing, either electronically or you can snail mail them in. And or anyone who has thoughts, points, questions, things you'd like to ask, please put them in a comment. And so then we can have those answered and clarified. So I don't see any more questions. And so that concludes tonight's meeting. On behalf of DOE and the entire project team, we want to thank you. Colleen is dropping a survey into the chat so you can tell us how we did in the meeting. And we'd like to thank you all for coming. We appreciate it very much and have a nice, safe evening. Thank you.